So for our panel discussion, we are very excited to have a panel moderator who is really part of our CASPA family for many years, Christy Wang. Christy is currently the president of Banquet-AI Incorporated and is a serial entrepreneur and investor in the medical device field. She co-founded and invested in a couple of medical technology companies responsible for products such as non-invasive glucose monitoring system and AI-enabled spine surgical robots in spinal fusion surgeries. Christy is experienced in medical product design using biosensors and predictive analysis, as well as investment, merger and acquisition, and capital markets in both US and Asia. Before founding her own companies, she worked for Hewlett-Packard legal department focusing on investment and intellectual property. Christy was awarded the most outstanding overseas youth Chinese by the State Council of People's Republic of China and met with Xi Jinping in 2015. Christy studied at Northwestern University and received a JD from the School of Law and an MBA from Kellogg School of Management. She is also a graduate of Northwestern Medical Innovation Program. Ladies and gentlemen, please give it up for Christy Wang.
Thank you very much. Well, thank you so much for the extensive introduction of me. Well, it's my great pleasure to be here still hosting this event this afternoon. And we have, as you can see, a very stellar team sitting here. So first of all, ladies and gentlemen, let's give a big round of applause for our panelists today. Okay, we have 1 hour sharp. Okay, so in order to make the full use of all the time that we have, what we're going to do is, number one, I'm going to make a very brief introduction of each one of them. And then each panelist will give a 3-minute presentation talking about their company, their product, themselves, and their perspectives on different topics. And then after that, we're going to talk a little bit on the technology, the adoption of the technology, as well as the regulatory issues and concerns we have. Finally, we'll open the floor to all of you. So if you have any questions, think about it, and then raise your hand as fast as possible. Okay, so first we got Mr. Robert Blake. Oh, okay. And Robert is the president and CEO of Acronics Semiconductor, and he has brought to us more than 25 years in the industry, with roles in product development, sales and marketing, and management. Robert, welcome.
Thank you very much.
Hello.
So it's my great pleasure to be supporting another CASPA event. I'd like to thank Danny and the rest of the executive organization for this opportunity. I continue to be impressed by the way in which this group organizes, puts on a variety of different events to promote technology, industry, and learning. And so I appreciate the opportunity to join you. I'm going to just give you a very brief introduction so that we can get on with the discussion. But I work for Acronics Semiconductor. We are in the business of building chips and IP that is aimed at doing data acceleration. It's a very exciting place for us to be. We build 2 kinds of technologies. We build high-end chips, and we also license our IP for integration into SoCs. That's a unique business model for us. In general, we focus on a number of areas. Data center acceleration, both in the core and the edge. We focus on wireless infrastructure. We focus on networking, and we focus on automotive products. So a variety of different things. The company has been around for some time. We're actually based in Santa Clara, right opposite the Hyatt Hotel on Great America, and we're continuing to hire people. We're looking for experienced people, both in the technology development as well as in software development. The company has been recognized for a number of different awards, both in terms of its innovation, in terms of products and capabilities, and I'm very proud to be a part of that team. If I looked at the end markets, these are the things. Obviously, we're going to talk about AI and machine learning. We're going to talk about those adoptions. These are the areas in which we think that things are most exciting for us to work in. And so we look at things, obviously, in computational storage. We look at things in both compute in terms of core and edge. we look at networking, we were getting very, very fast packet streams of data that we have to do. Very exciting marketplaces, all very fast growth rates. I think you see a lot of information about that. For us, latest and greatest products, we build high-end FPGAs. This is an example of our 7nm technology. If you look at this as a computation acceleration chip, it's built on ASIC technology as well as emerging FPGA technology. And what you see is several things. We innovate in terms of memory bandwidth, both from a GDDR6 and DDR. We have massive amounts of serial data coming in through PCI Express Generation 5, as well as 400 gigabit Ethernet, so we solve the connectivity problem. And then really at the core of the chip, we do very flexible integer and floating point arithmetic to do acceleration. And so the combination of these things we think is very well suited for the variety of different tasks that you're going to see in terms of acceleration capabilities. And our belief is this. ASIC technology is going to be very strong. You're going to see GPU technology. You're going to see CPU technology and FPGAs. The piece that we believe that FPGAs does very well at is it combines very great flexibility and performance, but the ability to change. I think what you're going to hear today is that there's a lot of interest in algorithms changing, workloads changing, solving new levels of problems, and we think that we've got the right kind of mix between flexibility and performance. Finally, what is also unique to us as a company is we do provide and license our IP. So as other companies are interested in integrating this acceleration technology in their own chips for their own applications, we will license a piece of technology to go into that. And so in general, we have something that's like an FPGA compiler. We can customize those things and license that. So standalone FPGAs, licensed IP, and a set of software tools that enables algorithms to serve. Thank you.
Okay, just now you mentioned a lot of new technologies. What do you see are the barriers for the adoption of all of this new technology?
I think that there's a number of things. Obviously, the silicon level technology is providing great flexibility and improvements in performance. The real challenges lie on top of those things in terms of software tools. I think that if you look in the development environment, a lot of software development engineers that are building exciting new algorithms and new workflows to solve those problems. And so I think the big innovation and the big breakthroughs will be in the software tools that will enable people to go from creating new algorithms to solve workload problems and driving those down into these types of new silicon architectures. And that's a big focus for us.
Thank you very much. Thank you. Okay, second we have Ian Peterson. And Ian is the owner of Idea LLC. And he has tremendous experience, in a lot of different areas like autonomous vehicle space, the drones, and he also, provides a lot of aspects on artificial intelligence and machine learning. So Ian.
Thank you.
Richard.
Tremendous experience, that probably means I'm old. I think to echo Robert's point, I've been a passionate fan of CASPA. I was at ARM. I drove the renewal of the relationship between ARM and CASPA, and so a couple of months ago, I was invited to come and talk about AI. Vida is, I'm a consulting, so I'm just running around talking to different people. And I was like, what do you want me to talk about? I'm like, anything is cool. Okay, so I basically have this one, right? It was really good. It's a really good slide. Robert. Yeah, no. Who looks better, Robert or myself? So,
This is Ian Peterson.
Yeah, we look so similar.
And by the way, I think these two guys actually knew each other for how many years?
That also sounds like I'm old. Right? A few
years.
When Robert was at Altera. So I'll talk about three things and then the slides can catch up. So the first thing, there's been incredible investment in the AI space. I've got a slide which is really cool. It shows the investment stuff, and we are heading for a bad time, folks. Okay, there is going to be a very, very challenging dip, the trough of disillusionment, as Gartner would call it. There is going to be a lot of consolidation. Just because you can build an AI chip doesn't mean you should. Okay? Oh, yeah, there you go. Oh, it was so close.
they really like Robert. It's like, Ferguson's so ugly, I'm going to keep with Robert. So, oh no, it's wrong! So the first thing is, there's going to be consolidation, and I think the other message is, clearly, semiconductor guys are not alone. The people that know the workloads in the cloud better than the silicon guys are the cloud guys, right? And there's a very big silicon capability. The gentleman next is going to talk about some of that from Facebook. Alibaba have created a device. So this marketplace is really, really challenging. It's taking longer to get to money. So that's the first topic. We're going to see a tough winter in the next. I think 2020 is going to be pretty ugly for consolidations and companies going out of business. The second topic is stop talking about tops. Okay, we need to get to the place where we're talking about specific benchmarks for specific applications. Go back a little time. Because I'm old, DMIPS, right? Everyone was talking about DMIPS, and in the computer industry, we created specs, so we could actually understand a representative benchmark for computing. And we've got to get to a similar place for, hey, yeah, this is exciting. So stop talking about tops. We've got to get to a place similar to what Spec did for compute benchmarks and Embassy did for embedded benchmarks. We've got to get to a similar thing for the machine learning space. MLPerf is one, where they're starting to look at speech-related benchmarks for inference, for training. That we have to go down that path. And I think for whatever you're doing, to my last point, be specific about what you're designing and for whom. This whole sort of top stuff, got to stop. It's going to be how many images do I process? How quickly do I do inference on a second of speech? Whatever it is, optimize for that. And my third topic is predicting the future frameworks is hard. My other gag was if I was really good at predicting the future, all of my stock picks would have worked out. And I'm still working. So it's really, really hard, right? Just over the last couple of months, JP Morgan have shifted their main algorithm from something called Black-Scholes to random forest. There's all of this activity around Microsoft with OpenAI, brand new frameworks. And so the challenge is if you just purely design an ASIC for that next thing, by the time that chip comes out, that thing will have changed, right? And TensorFlow's adapting. So I really do think, and this wasn't a setup for Robert, honest, money later, there is going to need to be some configurability. You're going to need ASIC because you're going to need that compute and that throughput, but you're going to need some get-out-of-jail-free cards with some programmability. So those were my three slides that you find missing. Thank you.
Thank you, Ian. One question. So just like you mentioned, the consolidation is coming. Okay, it's irreversible.
Yes.
And who do you see in this environment as the loser and the winner?
Whoever can get my slides up. I think, so I think the reality is that the cloud guys will optimize for a specific workload. In this space, one size does not fit all, so the fact that there's a capability in Amazon and Alibaba and Facebook doesn't mean that they're going to do everything. So there is still a market for other people. I think what's going to be challenging is for these startups is they say, look at my tops. What's happened is you've got an incredible amount of software that's built up around from these traditional suppliers. This small company called NVIDIA is doing quite well. Xilinx is putting a lot of investment in there. So I'm not going to say who's going to lose. What I hear in the marketplace and what I see people in terms of the startups, I hear a lot about Habana Labs. They seem to be the one in the startup world that everybody's benchmarking against. Again, one size does not fit all, so there's some others on the edge, like Scintium. But if I look in the cloud, I like what Habana Labs is doing right now. But it's a very dynamic market, and I just told you about how good my stock picks are.
Thank you very much.
No problem.
Okay, next, we got Ron Ho. And Ron is the Director of Silicon Engineering at Facebook, focusing on custom silicon chips on AR and VR. That's exciting. And prior, he spent time at Intel, Sun Microsystems, and Oracle. So, Ron.
Thank you very much. Does it work? Yeah. So thank you for giving me the chance to talk today. I like the title AI Reality Check. I just thought about it. It's interesting. It makes me think we're going to debate whether AI is real or not real. I don't think there's a lot of debate there. AI is here, it's omnipresent, it's real. And we know that it's in the mainstream. And in fact, it's more than the mainstream because due to the ready availability of things like labeled and curated data sets for download, the frameworks we have for programming, use the Python book, and you can do this. Now don't take my word for it. If you'd like to know for sure whether or not AI is in the mainstream, there's a very clear litmus test for whether that's true or not. Go to Amazon and you look for the dummy books. And they're there, right? So clearly it's part of the mainstream, it's easily available, and anybody can do it, which is great because that means that today a number of very smart people can actually take these powerful techniques and solve the most pressing problems of our generation. What would that be? Telling whether or not it's just blueberry muffins versus chihuahuas. This is actually really hard if you look at this. I'm like 50-50 on this myself. You can look at this later. Okay, so it's clear that we can use these techniques, they're very powerful. What's next? What's the next set of applications that can really benefit from the techniques and abilities that we get from AI and ML? Well, one of the areas that we're looking at certainly is augmented reality. So many of you know about the movie Ready Player One or the book, the virtual reality, the big goggles, you put them on. They're a lot of fun. I put them on, I look like an idiot. My dog's like, what are you doing? That's virtual reality. Augmented reality is a little bit more about the mainstream. It's about putting on a pair of glasses you can wear about in daily life. Goggles with the big, like the ski goggles, that's really it's in privacy of your own home. Glasses you wear everywhere. And if I could wear these glasses all day and have them give me little bits of adjusted augmentation to my life, if I'm in an unfamiliar airport, it gives me maps on the road, on the pavement, telling me where to go for my terminal. If I'm in an unfamiliar country, I can read menus by having it translate words for me. If I see a friend I haven't seen in a few years, it can gently remind me what that person's name is. Right? These are little bits of superpower that I can really use on a pair of glasses, but they'll have to be socially acceptable, right? I used to wear glasses, many of you wear glasses. If you wear glasses, not a big deal, because they're just glasses. They're not glasses, right? They're not like big, huge things with a cable or a big bolt on the side for a battery. You can't have that. They have to be very socially acceptable. They have to be lightweight. They can't be painful to wear or bend down or slip down your nose. They can't be hot. I'm a chip designer. We talk about 100-degree junction temperature. Not around your head. Right? They have to be very comfortable. They have to last all day. I can't put them on, have them 20 minutes later start telling me I'm low battery. So that's hard. And not only are these user requirements challenging, there's other sorts of requirements such as privacy. I can't have my own personal data flying out of my glasses so that somebody on a Wi-Fi network can snoop it and figure out what's going on. Latency. Let's say that, so next year I'm running into Christy at a party and I'm not sure what her name is, and it's really that awkward thing where it's like, hey, how's it going? And I don't know your name. But then she walks past and 2 seconds later my glasses say, oh yeah, it's Christy. I don't have time sometimes to go to the cloud, to go to a computer. And of course power, I've got to run all day on a pair of batteries. And if you look at a pair of glasses, look at the batteries. There's not a lot of volume. So it's challenging. What does that mean? It means that although today AI is real, it's omnipresent, it's available, grab some Python books, program stuff, it runs in the cloud, it's great. This is not the cloud. This is really a move towards AI custom silicon. Despite what Ian just said on the slides you couldn't see, we do think we have to move towards custom silicon. Why? Because the energy, the latency, and the privacy. So the good thing about custom silicon, we know all this, right? We know that's great because the energy efficiency of custom silicon running on a customized workload is easily 1,000 times higher than running code in a processor. That's well known. It's well understood. It's not our work, it's out there. We can tune everything from the physical geometries, the packaging, the positioning, to what you want for the exact workload. Now, of course, custom silicon also sucks. Right? It's terrible because it takes years to build. It takes $1,000,000 to build. And as Ian pointed out, by the time you're done, your algorithm has changed immediately. And that is why over the last few years, we've seen this gradual shift away from custom silicon towards these sort of universal compute substrates. FPGAs, right? Compute accelerators that are generalized, we've seen that. But if you want to live on the edge, if you want to actually have the ability to do stuff in a small form factor, with low latency, with guaranteed high compute throughput, very small battery consumption. It really has to be custom silicon. So I think what's going on is AI is driving, the reality of AI that is driving us as an industry, that we're all here to really push custom silicon for AI. And how do we enable that? What has to change in design methodology, to generators, to rethinking how we build chips? And that's what I think is really interesting today. Thanks.
Thank you, Ron. I got one question for you. You are actually a silicon guy, but you are in a software and social media company. So, this is a very interesting dynamic here. So, what do you think is easier, from the software to the hardware, or from the hardware to the software?
It's a great question. They're both really hard. The reason I'm at a software company is because they have really good lunch.
And dinner, right?
Well, breakfast, lunch, and dinner. You can't get that at hardware companies. And
That's true?
That's enough, right? Well, no, it's a good question. I think we are seeing these double trends of software system companies trying to build hardware. Google, Facebook, Amazon, and all these companies, and the BATs, right? Baidu, Alibaba, Tencent, they're going from the software stack down into the hardware and even down into custom silicon. And then you see like custom silicon companies trying to go up the stack and build systems. Which one's easier, which one's harder? Well, I think it's actually pretty obvious. The companies that start from the software stack have a built-in workload, they have a customer base, they know exactly what they want to do. So building hardware is a matter of hiring a bunch of old farts like me to come over there and do that there, right? Because that's relatively well understood. Taking some really cool solutions hardware and coming up the stack is actually fundamentally harder because you've got to invent a market. You have to say, I'm going to do this new thing that nobody else wants to do, and I'm going to show them something really great that they're going to do. Possible, and there's exceptions at both sides of that fence. But I think generally it's easier for the software companies to come down the stack.
Well, thank you very much. And I also wanted, one more. I wanted to open this to actually the whole panel here, because I think this is a very interesting topic, isn't it? So let me introduce the lady here. And this is Anne Gui, and she is actually from Cruise, an autonomous vehicle company, and she's also driving the hardware development in a software company. So do you agree with Ron?
I have to say I agree. And also, we have free lunch, free breakfast. And our investment is huge compared to the hardware company that, it's really hard to get a lot of investment. But seriously, I totally agree that when you have a good market, when you have a mature software stack, it is relatively easier, of course they're both hard, to fit them into a hardware system. So they're saying that if you're serious about software, you should be serious about hardware. So that's what hardware can help the software to make a great product.
Thank you. Thank you. Do we have any different opinions on the panel? Robert? Ian?
Yeah, I've always got strong opinions about things. I think that the software problem is a large problem, but I think that in the example that Ron has building custom silicon, I think that when you're building some things that have got very specific goals of size, weight, power, then sometimes you really have to take a custom approach to solve it. That was I do agree with. I think generally though, I think hardware companies are able to understand the abstractions in terms of the capabilities that they're building and deliver solutions where they can learn about the software workloads and the types of flexibility that they need and build those in. So I have a different opinion. I think that problem can be solved. It simply depends on the classification of the problem you're trying to solve. And I think that's where companies can build very creative silicon solutions and tie those tightly into the software environments.
Thank you. It's very insightful as well. Okay.
Maybe I'll... So I think two things to add. I think if you're doing both, it's much easier to do the security. So one of the topics we'll talk about, if you control both pieces, I think you've got a much better chance of building something for privacy, for a car that isn't going to get hacked driving at 70 miles an hour. I think the second piece is, and there's clearly a shift towards ASIC development in Alibaba, as I mentioned earlier, and obviously Facebook. places like that, Tesla building a chip. I think it's going to come back at some point, because there's going to be places where those companies absolutely want to own the silicon, either for brand reputation, because it's their brand on the line if it gets hacked, or other values that they're going to get out of the silicon. The reality is, in some other places, they're going to be, this is just better for us to have a broader set of technologies out there. So I think there'll be some picking of places where ASIC development is exactly right, and I don't think places like NVIDIA, Qualcomm, MediaTek are going to be going anywhere soon. I think there's still going to be plenty of business out there. The challenge is going to be, which are going to be those ones, and how does that relationship work between the two?
Well, thank you. Do we have any opinion from the academia world?
I totally agree with you guys. I think right now the AI is pretty dominated by software. But if you look back at the history, right? 10 years ago, it was driven by more of the hardware development to give more computing power that enables them to compute and iterate those algorithms as fast as they can. And gradually, when the algorithms become ready, and I'm going to present some part in my talk, I think the hardware will come back to catch up and enable those new algorithm applications down the future.
Wonderful, thank you. Okay, so let's move on to our fourth panelist, Ian. So, do we have Ian here? Okay, so you changed your face.
Oh, okay, yeah. So,
Well, actually, the CEO for Smart Giant, who is Mike Zhou, is not available today. So Ian Wen, who is the technology director at the company, is representing Smart Giant.
yeah, thank you. The company, today topic I want to talk about is leverage AI for the industrial applications. You talk about a lot of things in like everyday life and interesting things, and this one is industrial application directly. So let's take the traditional visual inspection versus the AI solution as example first. So the traditional one for the industrial vision inspection, it has very long period of R&D time, and it's very challenging for it to take atypical cases, and the threshold is also very high. Well, when you get the AI involved, the deep learning vision inspection involved, you improve both efficiency and the accuracy, and also the life will be easier for people who work, because all hardware can be done by the AI. So we take example here, a flexible PCB visual inspection, all these kind of defects, so like the scratch, this overspill, all these things, develop time, resources. 4 engineers in 6 months can do the job for the traditional algorithm, which reaches about 80% of the accuracy. While when you get AI algorithm involved, is 2 engineers in 2 weeks, 97%. If you give more training data, it will do better. So the question is, okay, because you see that even though AI is good, but the machine there is very big, right? How can we make it smaller and also faster and less expensive? So what we do here is we want to move all these things to the edge and use building those computing power into the cameras. So the AI camera is one of the products that we have. We have a barcode scanner, and which will actually look at the barcode, because in the testing, each and every component has a barcode to identify, right? So, and also we have the binoculars, camera module, and binocular with the depth information where all the AI calculation, the computing we're building. And if it's not enough, we have the edge computer to expand it. Here are some examples of how the barcode scan plus AI visual inspection is done. You can check detect the thread and dimension. You can read the optical and object positioning, and so on and so forth. Okay, the next question. So, any more applications in industry that we can have for AI? So, we know that FPGA is one of the good solutions. Well, I guess Robert will agree with me, right? And for the endpoint applications, the challenge for FPGA is that it is very, it needs a specific skill set. Therefore, Smart Giant provides a very take the initiative to make the the toolkit and the SDK for the general developer to be able to use it. You can see that we have to set up the toolkit, SDK, and to build the firmware on top of the hardware. And also we make it very easy to drop and make this toolkit together. And we have also a set of FPGA and other hardware modules that were verified, and at the bottom we can put together as the AI solution. And that's about it. Thank you.
Well, thank you. Thank you. So just now you mentioned that Smart Giant provides the toolkit and the SDK, right? That I think which is very easy for the non-FPGA engineers to implement to simplify the whole process. But as far as we know, that Xilinx actually recently announced its deployment of Vitis, which is also a very unified software system. So do you see any conflict or collision between the two?
No, of course not. Do we have any Xilinx guys here in the audience? Well, what I want to say is the Xilinx, the Vitis was released a couple of weeks ago. That we were at the XDF, observing that actually. The thing is, we are not a collision, but we are augmentation to it. Because for my company, Smart Giant, we have a lot of experience, especially on the endpoint, where we use a lot of interface and all the variations at the endpoint that deals with all kinds of industrialized information cases. Where for the Xilinx Vitis, it is more on the edge and the cloud side. Of course, at one point I think we can either augment to it, or we eventually can transfer to that platform.
So it's more complementary.
Exactly. Yeah.
Okay.
Thank
Wonderful. You. Okay.
I can't leave without to add a few comments to that. I think one of the things that's really quite exciting is that people are recognizing that there is a lot of performance advantages and flexibility in FPGA technologies. And I think the fact that there are many companies, both on the open source side of things, building frameworks to enable the unlocking of that flexibility and power, and to improve the algorithmic development in terms of that porting and the ability to go from TensorFlow or Caffe and implement things in an optimized way. That is a big development, and we're finding a lot of people that are starting to work on that. I think that in general is good for the industry as a whole.
Thank you.
Thank you, Robert. Okay, next we have Professor Yu Cao. Professor Cao is from ASU, Arizona State University, and he's a professor of EE. Professor Cao's research focuses on brain-inspired computing hardware design for on-chip learning and reliable integration of nanoelectronics.
Thanks, Christy. And I'm probably the only academic person here.
Yes, you are.
So I'm going to share some ideas with you in AI. That's not a reality yet, but hopefully open some new design and business opportunities down the road. So this is online adaptation we are working on. So as addressed in several previous talks, the AI happens today starts from the cloud. You connect a bunch of big data, and you train the model offline. And after that, you pass this model to the edge device, and the edge device, like a mobile phone or other ones, will recognize some class in the market and other stuff. Just do the inference only, right? If we look at the emerging, the future dynamic systems, we have seen a quite different picture here. If you look at the cell phone, or the self-driving vehicles, the robotics, and even the airplane, right? They have much more computing power than the past, than your cell phone or your watch, but they don't have as powerful as cloud. And if you look at the user scenario, you have seen that they have an increasing need of online adaptation, which means that the model for pre-trained in the cloud should be adjusted in the field, essential to the incoming streaming data. For example, most of the self-driving cars are trained in Phoenix. And how about we use that one to California by the ocean coast? Can that one take and sense there's a wave coming and do some reaction to it for the first time? Or can medical device with some generic knowledge inside be customized easily and adapt to an individual patient of that? So those are capabilities we are missing today, and hopefully by joining the effort of algorithm development and hardware together, we can achieve that. This is not just imagination, right? This one actually has been done in nature for millions of years, and we are gradually more and more evidence from the biology and neuroscience to understand what's going on. So if you look at the neural cortex of a human being, V1, which is the unit here, can recognize most of the features. But it is through the long-term feedback from the later stages they can recognize attention across different contexts to create all the objects together to sense it's in the meeting place or other things. And if you look at an even tiny insect like honeybee, it can quickly adapt to one flower to another flower using some unit called antenna nu. It is only 1% of its brain. But with this unit here and with the feedback down the road, it can adapt from one flower to another flower in seconds so much. And such ideas has inspired the machine learning community to generate a set of algorithms, including the transfer learning, domain adaptation, reinforcement learning, continuous learning, all recent graph-assisted prediction done by 50 years ago. And to put those algorithms on chip, it takes even more efforts from hardware, because such hardware does not exist today. Right? Our hardware is sort of feedback loop of that. And also many companies have been spending lots of time to exert just inference only. Now we're applying not only inference, but also the feedback, the adaptation at real time with that short time of that. And one of the ideas we are working on, and that's promising, is to combine the unique features of the on-chip CMOS circuit and also emerging non-volatile memory together. Those non-volatile memories have high storage density that could store the memory and the model on the chip, and then add the feedback loop of the SRAM, it can quickly adapt to new knowledge engineers. And the challenge is not only just to integrate all those devices together, but also in design side. Because now you need the in-memory computing to exert all the paths together to achieve real time. But also you need to add the independent fabrics, like those reconfigurable ones, to connect all those modules together and give you enough adaptivity depending on the algorithm you're going to do. The last but not least note is this. If you look back, right, we know that our machine cannot be agile as a honey, and our machine cannot be intelligent as a dog. And we used to blame it is because our algorithms are not ready. But if you look at this figure here, this one plots all the different algorithms in terms of the connectivity and also the neurons. It actually exceeds the level of a fruit fly, a honeybee, and even close to the human level of that. So, as a hardware designer, we cannot blame the algorithm anymore. We have no excuse that our hardware is because your algorithm is not ready. Actually, it's the hardware that can be hyped right now. So I do believe that, look at the trend here from different companies. The software companies are looking for the hardware community for new solutions and new innovations over there. Online adaptation may not be the only answer we're looking for, but hopefully that can bring some advance from today.
Thank you very much. Thank you. Professor Cao, you actually, I think you touched upon several very interesting topics. I think one of the things you kept mentioning is neuroscience. Okay, that's pretty new, right? In addition to hardware and software. So what do you see the role that neuroscience will play in the new era?
I think it's a mutual interaction. In the past, neuroscience people and machine learning people, as you may know, that they don't get along with each other. They look at it from different aspects. One neuroscience, pretty small scale, and one is sort of large scale mathematical operations. But now with the advance of machine learning, actually they can use that one as experiment to help understand neuroscience. And with new computing power, they can do more detailed, fine granularity analysis of the neural activity. And now those principles can generate new mechanisms for machine learning people to improve the algorithm. So I do see the more positive interaction today.
Thank you. Anyone else? You want to chime in?
Yeah, so I think I'm very excited to see some of the work that you're doing. A piece to me that seems the hardware pieces need to catch up is, if I kind of compare to the CPU world for a very long period of time, often performance, you can build a very hardware-centric engine, but unless it's busy for a high proportion of the time and it's not stalled or cache missing, then you don't get that performance. And so I think that the architectural development is really going to focus on not just building a smarter computation unit, but solving the memory bandwidth problems and solving the connectivity issues of how you get the data in and out. And I think that that's where the innovation needs to come from on the hardware side to enable the software algorithms to run much more efficiently by solving some of those fundamental problems. Great.
Thank you. Okay, so finally, last but not least is Ms. Anne Gui, and she is the Senior Engineering Manager at GM Cruise. Welcome.
First of all, Professor Cao and everybody is trained in Phoenix. We're not trained in Phoenix, we're trained in San Francisco. So for the ones that do not know Cruise, we're the autonomous vehicle company based on Cruise. And we are using General Motors GM Bolt as our autonomous vehicle. And thanks to our amazing software and hardware team members, our vehicle are able to maneuver through one of the most challenging urban environments in downtown San Francisco, fully autonomously. I brought a video from Cruise. I hope I can play it with music. Let's see. It's a bit challenging engineering problem. With the music. Can I play? Is there any way I can move my cursor to?
They couldn't even put up my slides.
Here we go. Okay. We need some AI here. Okay, thank you. Here we go. Thank you very much. Okay. So for Cruise, our mission is to build the world's most advanced self-driving vehicles to safely connect people with places, things, and experiences. So we're trying to solve one of the most challenging problems of our century. And Cruise believes that the future vehicle will be connected, autonomous, shared, and electric. So these are the 4 things that's driving behind our vehicle. So have you ever wondered what is underneath this vehicle? How does it look like? How does an autonomous vehicle look like underneath the hood? So this is a picture of Cruise vehicle. Just like human beings, there are sensors. These are our eyes and ears. So we have LiDAR, we have a radar, we have camera, we have speakers and microphones to take images and audio sounds around the vehicle. And this sensor output will be sent into the brain, that's the CPU, to process. And the output of the CPU will be sent into the control unit, that is to drive the car on the steering wheel, on the brakes, on the transmissions, and so that the vehicle knows when to make a turn, when to stop, to avoid different things that you see on the road. So if you go to San Francisco, you should see that chances are you will see one of our vehicles running on the road under training. And one little secret is every Cruise vehicle has a name. Some are called a piglet. They are taco. They call it avocado. Just to name a few. So if you see a vehicle, be sure to look at a ribbon, and you will see its name. And we kind of try to personalize this vehicle, so they are just like a human being. Thank you very much.
Thank you. Very exciting, very exciting. So, and, we all know that you're actually, driving the hardware development in a software company. So what do you see the relationship between these two in your company and Cruise?
That's a really great question. So Cruise started from a software company, like a lot of other system houses or big companies. So I think our first vehicle, there's only a couple of mechanical engineers, and they try to screw a CPU onto a vehicle, and then run a lot of stack of software. So when the vehicle progresses and when our hardware, when our software stack gets heavier and heavier, we find the limitations. We find that there are need to drive the processors, there are need to drive the sensors. So gradually, the company add more and more resources into the hardware, because we believe that this is a hard problem to solve for everybody. But in order to solve this hard problem, the only way is to collaborate between hardware and software. And the more connection you have, the better off you have a chance to solve the problem.
Wonderful, great. And one related question to autonomous vehicle industry, and I believe that every one of you here might be interested in this question too, is how long do you think it will take? First from here, L3 to L5. Are we going to see it when we're alive?
You will.
Thank you.
Yeah.
Me and Robert, maybe not.
I'm sure one of all of them.
It's an excellent question. So try to answer this. I think probably there will not be one day when you wake up all the vehicles are autonomous. It will be a gradual progress. So from what I can see, maybe starting from some urban areas that you have a good need, people don't want to drive, parking is very limited, and there are like complicated road conditions, one-ways or no turns. So these are the areas that a trained vehicle can be put off good use. So I can see that in the near future, I cannot say how many years, but these vehicles will be available in those urban areas, like San Francisco, like Phoenix, or some other areas. And then gradually, more cities will adopt this, and then maybe from urban to suburban. So it will be a maybe long, maybe not too long progress, but it will come.
Okay, great. Thank you.
So maybe a couple of data points. So one thing that I've heard, and there's a number of things out on the web. If you think about an aircraft has about 20 billion lines of code. Like the Joint Strike Fighter is about 20 billion lines of code. The estimates are for level 500 billion lines of code. Okay, so I think for me, level 5, which is no steering wheel and you can drive in any conditions, I think to Anne's point, that's quite a long way off. I think we are going to see constraining of the problem and say in this particular area we have enough control over our environment that it will happen. I think people are going to skip level 3 in general, because if you go towards like that, the big flip there is liability from the person over to the car. And I think people are going to skip level 3 and go straight to 4. And that's 4 is important because for Uber to make money, you've got to remove the person out of the car. So for this fleet model to work, that's really the push. And I think the third leg to the sword is to talk about China. There are, I think to Anne's point, the one company can't do all of this. So if you look at Baidu's activity with Apollo and a number of these other activities, they're pulling a lot of people together into these systems. And I do think China, Baidu actually released a level 4 bus last year. I think if you look at what China does, you can imagine like a brand new city being built. If you can build a brand new city without the legacy, I think that's the sort of constrained environment that you could see it actually happen quite quickly. And I think while we're in the US making sure we're doing everything around roads, and I tell you, driving on 101, I want autonomous vehicles because people suck driving. So, but I think China's going to happen a little bit quicker. And I think because of these brand new cities being built for purpose, you're going to actually see it deployed there maybe a little bit quicker. I think the tech is behind right now, but the investment over there is extraordinary. And if you think about people like Huawei putting in infrastructure that will be able to send in additional information to the car that blends with the sensor information in the car, in a brand new city in China, I think it could happen a bit quicker there than here.
Well, thank you. I think a limited question to this one is, so what are the limitations for the adoption of this trend?
And you should start your place.
Yeah, start with Anne.
Okay, that's another good, nice question. So there are a lot of limitations. So I think I probably wouldn't call limitations, maybe the challenges.
Challenges?
Yeah. So from my personal opinion, I think safety is the biggest thing for us. Nobody wants to step in a car when they have a doubt that they cannot take control as of today, that they will fully give their responsorship to a machine. So as an industry, I think we need to make sure that we give the consumer enough confidence that our car is safe. And that's the focus of, I believe, most of the autonomous vehicle company right now are. Yeah.
Thank you.
And I think building on that, this is going to really change. If this happens how we portray it, right? It's going to really change. Car insurance, it's going to go away, right? 95% of accidents in the US are a person's fault. Okay, so if the cars are now doing it, who's going to, car insurance, personal car insurance, how does that work? Dealerships, go, right? It's fleet model. And so there are challenges that we've got to work in our industry, but there's also incredible resistance from these other industries that are about to get disrupted. And they might put it around things like, oh, we're worried about safety and things, but there's also some protectionism going on. And I think it will happen, and that's why I think it will happen in certain places quicker than others. But it's definitely safety. I think the other thing is this tech is expensive right now, right? You're not going to see this sort of technology fitting into an electric vehicle in India anytime soon. So there has got to be, back to Dr. Yao's point, I mean, there's got to be brand new hardware innovation to drive this down, because at the moment, this thing really is only going to be able to support sort of high-end fleet models which are running, let's say, 23/7. The thing goes back for an hour to get recharged, get downloaded. This is not going to be your $10,000, $8,000 car in India. So this tech of LiDAR, batteries, sensors has got to come down. There's some work at the moment going on about limp home modes. So you can't have, let's say your LiDAR stops working, right? Your normal redundancy, you're not going to have backover systems, right? What happens if your camera systems fail? So the industry's having to work on, it's like, how do we limp home with the information that we've got if LiDAR goes down, or if our main ADAS system goes down. So a lot of those things have got to go on. That means that you can't keep putting lots more hardware in there. And so, I think beyond safety, this thing's got to get more cost competitive to drive an ROI.
Thank you. Okay, great. So I think just now Anne, give a very good description of the application of the technology in the automotive vehicle industry. And I'm from the healthcare industry. And just now, Ron was talking about whether this is real or not. So today, I actually wanted to show you something real. And this is the non-invasive glucose meter that we developed. So this one actually has a lot of application of artificial intelligence in it, because in the first generation, we have the patient needs to do at least 20 to 30 times calibration in order to use it. So when we're talking about calibration, basically we're talking about you still have to poke your fingers for 20 to 30 times, right? But with the artificial intelligence and with our team, who focus very deeply on the predictive analytics, and today we can actually reduce the time of calibration to less than 15 times. And then with more data in the future, probably in the next 2 to 3 years, we can actually reduce the calibration down to 5 or even 0. So this is actually very real right now. And from a FDA or CFDA perspective, and we know that the healthcare industry is probably the most conservative industry, right? Even compared with the automotive vehicle industry. So safety is definitely issue number 1. And efficacy or performance is issue number 2. So while we are doing this, we really need to think about a lot of regulatory issues at the same time. And one of the issues we are thinking about is privacy. So, we have HIPAA in the United States, and we have other, related laws in other countries. So that actually creates a huge burden or a huge hurdle, in the healthcare industry for the application of the AI technology. So I also wanted to open this, to our panelists. What do you think of the privacy and the security issues? Do you think that it's really hindering, the adoption of all of this new technology?
I think that there's obviously you look across all of the things we talked about today and the kind of revolution of things that are happening, and I think that wave is inevitable. Obviously, we're excited about autonomous vehicles. I think the ability to change healthcare is absolutely dramatic in terms of what it can do. I think that you are, particularly in the US, we're going to see that regulation and personal information is going to be a big issue. I think that will continue, and I think in some cases that will slow down some of the adoption. But I think fundamentally the goodness that I think that you're going to get, especially in the healthcare sector, for the types of improvements that can be made, are so overwhelming that the adoption will happen. And I think that we have to just work with the regulation committees and the privacy advocates to make sure that happens as smoothly as it can. Because I think the upsides and the opportunity for improvements in all of our lives is so great.
Thank you. Ron? I know you wanted to say something.
Well, yeah, the Facebook guy, privacy. I think, so Robert, what you said basically is that there's a utility argument that says that, yes, we're concerned about this, but the things we could do if we could do this stuff are so great. That'll be a driver. I think that the challenge really is that regulatory behavior on the part of companies is rarely the right place to live. And unfortunately, there isn't a lot of regulatory behavior on the part of governments that are kind of dodging these questions very actively. And unfortunately, if you have a company trying to set policy in a way that's presumably fair-handed, you're going to sort of piss everybody off. Right? The challenge of surviving in that kind of environment is that it's very difficult to navigate the right path when you can't really drive consensus beyond your own particular market. That's a challenge. By and large, though, I think you're right, that there is a utility argument here. So the question is, how do we then navigate that? Certainly the preferred path on a lot of people's opinions is to say, look, government should regulate this. They should put policies in place, and then companies can be held accountable or not accountable to those policies, those regulations. That's difficult to make happen. The next part about that really is, you got to make it in from the beginning, because possibly you talked about this, where if you start with privacy and security as your initial design architectural spec, you've got a chance. You can still screw it up. If you don't, if you try to bolt it on at the end, you're screwed. There's no way you can get that right. There'll be enough smart people who will find backdoors into your systems. You have to start from square one. That's certainly what we're doing. And so we're going to try to put these two together. Build it from the beginning, get regulatory behavior from the governments to set the policies so that we can be held accountable, and not try to reinvent the wheel in 5 places. It's a tough problem.
Thank you. Yeah, problems are here to stay. What about Professor Tao? Oh, and you have something?
Oh, thanks. Just share some thoughts, even from an academic perspective, we talk about this privacy or not, even though we are much more open than other areas, right, than the company. So the privacy is really a touchy issue, and especially with the coming 5G. 5G will dramatically change the roadmap of the self-driving entities, right? Bring the safety to the next level possible, but also it opens the door for all hackers to get into your car and maybe ship your car somewhere you don't want to be, right? So I would like to maybe let Anne share some more thoughts on that.
Yeah, it's another tough question. So I don't know if you have seen a YouTube video about 4 years ago. There are 2 engineers team up with one senior editor from Wired magazine, and they let the editor with a walkie-talkie drive on a small freeway running at 70 miles per hour and using a Jeep. Don't worry, Jeep had patched them up already. I'm trying again. So what they did is the engineers, they hacked through the entertainment system. And first they took over the car and increased the volume so the music gets really loud. And then gradually they took over the steering wheel, took over the transmission, and took over the brakes. Actually, at the end, you can see from the editor's face, he gets really scared because it is really something that he cannot control. He's in the car and he cannot control anymore. So this is, like Ron said, a security concern that we have, and we have to do it from the beginning. So this is something that every hardware we do, or everything we're looking to, safety and security, the fundamental building block, or building stone of our system. And I believe that every company has this built into the system nowadays. Yeah.
Thank you.
One thing I can assure you that cruise car should be pretty safe, because those two engineers now work for us.
Okay. That's the most important part.
Yes.
Okay. For the sake of time, I think we will probably have one last question for the panelists, and then we open up the floor. So just now, Ian, you mentioned, China, right? You mentioned China a lot, actually. You said that, China has some advantages in terms of the application of the AV industry. So now, the general question for the panelists, what do you see the ecosystem, the differences in the ecosystem between China and the US in terms of artificial intelligence? Anybody?
Sure, I'll go. So I think in terms of AI frameworks, I think there's going to be a lot of commonality between China and the US right now. PyTorch and TensorFlow. I can't see that people are going to sort of change too radically off that. There's all this code going around. But underneath, I think there is a sort of there's two things going on now, right? There's a in China for China kind of activity, and there's a in US for US kind of activity as a result of some of these regulations. And there is, for a while, there's been this small company called Huawei has done quite well. But you look now at, I mentioned Baidu with Apollo, right? If you go on and you look at sorts of companies, there's sort of JVs with Bosch or Continental, but there are actually tier ones out peering. And I actually believe that there will be silicon for automotive coming out over there. So I think you will see hardware ecosystems evolving over there. I mean, there's people building hardware chips for HPC over there and things like that. So I don't see the AI frameworks, I don't think those things are suddenly going to change, because I think there's so much software out there around those things. But I do think you're going to see diversity and also some pulling back in the US of tying sort of in US for US kind of silicon and ecosystem happening. Maybe even with fabs over here to control that sort of thing.
Okay, thank you. Thank you.
So boring as it is to agree with somebody, let me actually amplify those thoughts. So if I go back to the question of how do we build hardware, how do we build these ecosystems, there's a well-established industry we have right now in Silicon Valley on how you build chips. Right, we know how to build chips. You got to build chips. You figure out what IP you want to acquire. You go acquire it. You figure out which IP you're going to develop yourself. You develop that. You put them all together. Boom, you got a chip. Make a bunch of $1 million every time. The challenge for what we're seeing today is that model is being threatened, because ultimately we're moving to an age of specialization, which means that if we're going to go acquire IP from various companies, the problem is it's never exactly what you want, and you're increasingly unwilling to pay the cost of it not being exactly what you want. What do I mean? So I happen to be working in the area of a lot of analog IP and like PCIe. If you want a PCIe block, it's going to be designed for the worst case spec, which is typically a data center. But if I'm building something that's going to transmit from like here to here on a pair of glasses, that's not a data center, and I'm going to pay a bunch of energy for the overhead required for that block to be compliant to the worst case spec. That's a very trivial example, but if you look at all the IP that you could buy on various parts of the ecosystem, it's increasingly irritating to designers to pay the overhead for the worst case for those IPs. All right, in other words, standardization is great until standardization sucks. And we're at that point where we're increasingly worried about the cost of that. So where is the ecosystem that's going to rise up to deliver the specialization of all the various blocks that we as an industry want to start relying on? All right. Now, I don't have the answer. I'm not going to actually say that's China versus US, but I think the question of where is the talent, where is the development of technology, where is all that taking place? Where can we see that willingness to make fast and agile design teams that can create generators for certain kinds of actually end up being an expansion away from Silicon Valley in a way that's actually very interesting.
Yeah, I think that, I mean, the point you make though is that when you look at the kind of complexity of modern systems that are being put onto silicon, you, as a developer, you always have to make that choice of make versus buy. And your choice of that make versus buy is whether can you buy the piece that satisfies the specification and the requirements that you have, and will that accelerate your development schedule? That's a choice you have on every single piece you do. In the case one you may have is that when you've got a very specialized application where you have very tight size, space, power constraints, you may be forced to go down that further customization because you can't find the right things. But that's a choice. I think in general though, what you're seeing now is the ecosystem of building blocks is increasing. I think the adoption of gaining more performance out of silicon, people having to look at very different ways, whether that's chiplet, whether that's package solution, all sorts of new ways to try and squeeze further economies and power and performance out of chips. But I think that the capabilities for that IP ecosystem is critical, so that companies can build these complex systems very quickly. I think that's a fundamental. You're going to continue to see innovation in those areas here in the US and Europe and China.
Great. Anyone else? No? Okay, good. So finally we have a few more minutes left. Okay, so now let's open up the floor. And anyone else? Anyone? Yeah, okay. We got one question there. And the second one here.
Come on up here. Come on up.
Hello. I first say a word. That's MIT AI lab director said the AI is talking by people who don't understand. I'm not talking about you. But I will mention one thing is the Chinese university, Tsinghua University, recently released a self-driving motor bicycle, two-wheel bicycle, self-driving. Their system totally new, they mimic human brain, and very close to the real natural neural network, self-driving motor bicycle. That's too hard, but they are successful. What we can learn from them.
I'm waiting for the self-driving unicycle. I think that'd be really good.
Well, it has already been released to the market. Okay, one last question, I think, from this gentleman.
Hi, my name is Paul Huang. I have a question, maybe particularly for Professor Cao and Han. Regarding the automatic driving car, specifically for the personal car, for the public transportation bus, and for the truck, for the long distance shipping, which one do you think should become a reality in the first? Second, in which area the automatic drive car will become the application first?
Okay, thank you. That's a good question. So I think different company look into different spaces. Right now, I know that some company are working on the trucks, some are working on the cars, and the other are working on like a delivery kind of cars system, and a bicycle, of course. So different companies share different view. So from our company's point of view, we believe that personal cars is the one that we can save human work, save cost, and save the environment. Because once we can share it, we can save more. I know that other companies believe that a truck can also save a lot of benefit too. So honestly, I don't know who's going to be there first, but it's a booming industry, and everybody is working together towards this. And my personal opinion is, anyone who reaches there will benefit us and benefit everybody.
Maybe I see the sign, the red sign is on. So that's the answer. If you want me to make a bet, I'll bet which one has a earlier safety solution will be the one get a large scale mass production. So if you want bet from that perspective, I would say personal car might be better because it's lighter, smaller, and any accident with a truck will give a dramatic impact on the entire industry.
Yeah, I think that there are some self-drive trucks in constrained environments running now, autonomously. So if you're in just in a yard or something like that, or digging stuff out of the ground, there's some actual autonomous trucks that will pick up the coal and drive it to the place autonomously. The thing I want to mention, I think with trucks, the safety record, I think to Anne's point is, got to look at that. There are actually some places like Korea, I just want to mention that they're planning to put in dedicated lanes for autonomous trucks. So I think part of it is safety, but part of it is also where government goes and funds and encourages. And if they put in autonomous truck lanes, which would have sort of self-driving capability and things like that through that lane, that sort of forcing function from the government. I actually think sort of driving on freeways is an easier problem and showed all the challenges with San Francisco. So I actually think trucks are going to happen a little bit quicker because they're in environments where it's a little simpler to predict.
Thank you. Thank you very much, Ian. No, he raised hand first. Okay, one last question. That has to be the last.
Hi, my name is Yao Ma from Tokyo Electron. I have a question to Anne and Greg about the self-driving car. This is related with safety. However, now the situation in the United States is a traffic dangerous country in comparison with UK, Germany, Japan, because the traffic death rate is more than 10 per 100,000 population. And Germany, UK, and Japan are less than 5. So how do you think we can reduce the traffic deaths so as to similar, close to European country and Japan?
Okay, so
let's keep it short.
Okay, that's exactly the space that we wanted to help. So our cars, we believe that can largely reduce the human errors because the machines are designed to take those tasks with a well-trained and well-processed step. I hope this answers your question. I hope it's short enough.
Yes, it is. Thank you so much. I think that perfectly concludes our discussion this afternoon. And if you have any dying questions, you're welcome to talk to them offline. Okay, so ladies and gentlemen, let's give another big round of applause for the excellent panel. Thank you very much.